Welcome back. This is the third lesson recording for April 12th, 2021. So let's use what we've just discussed, the trig function and the Pythagorean theorem to figure out the area of a regular polygon when we are not always given both the apothem length or the sides. So to begin, we can divide n-sided regular polygon into triangles. Okay, that's the first step. And it has n apophthegms and n radii and n number of central angles. So the number of sides determine the number of apophthegms you're going to have, as well as number of radii you're going to have, and the number of central angles you're going to have. And all the central angles are congruent because we're really talking about congruent triangles that you're going to be forming. And as far as the apothem goes, we can divide the sides, this triangle, into two equal parts. Okay, so the apothem divides the sides into two equal parts. That means this blue length and the red length are equal in measure. And also the central angle is divided into two equal parts. And how do we know that? Because this triangle on the left and the triangle on the right are congruent by HL. HL is, remember the side congruence, side angle side, or angle side angle, or angle angle side congruence. If you satisfy those, then the two triangles are congruent. Well, HL is one of them. Okay, H stands for hypotenuse, L stands for leg, and this is only applies when you have a right triangle. And in this case, we do have a right triangle, and we know that H, which is the radii of each triangle is going to be the same. Okay, and the leg, this leg, the apothem is being shared by the left triangle as well as the right triangle. So we have HL congruence, therefore triangle on the left and triangle on the right is congruent, which tells us that this blue angle and the red angle are congruent. So that divides the central angle into two equal parts, as well as this side, blue side, and the red side, the corresponding sides of a congruent triangle. So they are equal, so that we can conclude that the apothem divides the side into two equal parts. So we are going to use this facts to calculate the area of a polygon level 2. So first thing is, when we're given the radii, in this case just the radii 14.5 of this triangle, then we can divide the polygon into however many number of triangles. In this case, we have a 8-sided polygon, octagon, so we are going to divide that into 8 sides, means 8 congruent triangles. And each of the triangle, we know that the radii length was 14.5. That means the other radii was also 14.5, and we have a right triangle. What about the central angle? Do we know the measure of central angle? Well, it's going to be 360 divided by 8 for the central angle. And we know that the central angle, and we're trying to figure out what the apothem length is, as well as this side length to figure out the side of this octagon. So to do that, we know that central angle, 8 central angles form 360 degrees because it's the total complete rotation is 360 degrees. So each of the central angle is 45 degrees, and that means that angle here is half of 45 degrees. So that half of 45 degrees is 22.5 degrees. So whereas for the left triangle, the angle measure we're dealing with is 22.5 degrees. How can we figure out the apothem length as well as one of the leg of this triangle? We're going to use cosine. Okay, because to figure out the bottom length, because this is the angle measure that we know it's 22.5 degrees, and this is right next to it. So this is the adjacent side, and this is the hypotenuse. So the trig function that deals with adjacent and hypotenuse is cosine. So it's going to be cosine of 22.5 degrees is equal to question mark divided by hypotenuse is 14.5. And that gives us that question mark length is 13.4. Again, you should be checking to see, does my answer seem reasonable? If you're getting a length that is bigger than the hypotenuse, you should be thinking, oh, I must have made some mistake, right? And then to figure out this question mark length, you use a sine function. Sine, that's opposite over hypotenuse. Question mark over hypotenuse, 14.5 is going to be sine of 22.5. So we can calculate the question mark length to be approximately 5.55. Then double that will be the length of the side, 5.55 times 2. The bottom is 13.4 times half. Remember, the triangle area is half times base times height. So that's going to give us the triangle area to be 74.37 units squared. Now that we've figured out one triangle area, we need to multiply that by 8. So for the octagon, we need to multiply this area by 8, and that gives us 594.96 units squared. So please take notes on this. When you're finding the area of a regular polygon, you need to decide the number of sides, because this is the number of congruent triangles that you're going to form, and then decide what information you have. Do you have the bottom? Do you have the radius? Or do you have the side? Okay, do you have all the necessary information? Remember, we want the bottom length as well as the side length to be able to figure out the area of the polygon. So to find the, you might need to find the central angle if needed, or you need to use the trig tools if needed, and then use them to find the triangle area, and then finally multiply the number of congruent triangles to find the regular polygon area. All right, so now you're going to be working on card number 11 to 16 of Desmos, and that's the last thing we're going to be doing. Okay, card number 11. Theta is studying the triangles formed by bottom and radii more closely. After some thinking, she claims that the blue segment is the same length as the red segment. The blue segment here is same as the red segment here. And the blue angle is the same measure as the red angle. Do you agree with her claim? Well, we talked about that with the slides. Yes, she is right. Why? Because with the left triangle and the right triangle are congruent by HL congruence. We're dealing with the right angle triangle, and we have hypotenuse of the corresponding sides that are congruent. Okay, hypotenuse because they are both radii, and radii are always going to be equal in measure, as well as we have a shared side. The bottom here is the shared side. So we can say by HL they are congruent. Okay, next sketch in the triangle whose area you want to find. What is the measure of the central angle? So I've just sketched the triangles. So we have a pentagon, 5-sided polygon. So we have 5 triangles. Okay, what is the measure of the central angle? Well, we know that the complete rotation is 360 degrees, and it's going to be shared by 5 equal measures. So it's going to be same as 360 divided by 5, which is 72. Okay, so the central angle is 72 degrees. Label the apothem x. Find the apothem's length. So now we need to label this as x. And if this is 72 degrees, what is just 1/2 of the 70 degrees? Because remember, 72 degrees is the total. That's 2 of the angle. So this angle is going to be half of 72. That's 36 degrees. Okay, now that we know that this is 36 degrees, and we know that the side length is 7 yards, so what do we know about this length? This length is half of 7 yards, so that's going to be 3.5. Okay, so then can we use the trig function to figure out what the apothem's length is? Okay, so looking at the left triangle, we have, this is right angle, so we know that we have, this is going to be adjacent. Actually, we're dealing, okay, so this is the angle, this is the angle, right next to it is the jx, so that's going to be the adjacent side, and this is the opposite side from this measure angle. Okay, so that tells us that it's going to be tangent of 36 degrees is going to be equal to circa TOA, that's opposite of adjacent, so it's going to be 3.5 divided by x. Okay, so then x is going to be equal to multiplying both sides by x and then dividing both sides by tangent of 36 is going to give us 3.5 divided by tangent of 36 degrees. And when I use the calculator, I get 2.54. Okay, see again, check, does your answer seem reasonable? If this is 3.5, does it seem reasonable that this could be 2.54? Yeah, that seems reasonable. Actually, when I think about it, it should be bigger than 3.5 because 36 degrees is less than 45 degrees. So this tells me I think I've made a calculator error. And when I check again, it is not 2.54, but it is 4.81. And that looks much better. Okay, 3.5 here, 4.8 here. That seems a lot more reasonable. So then to find the apothem, we use so the central angle is 72, and your job is to find the length of the apothem. And the next slide tells you how you should have found the apothem. You're going to use tangent of 36 is going to be equal to 3.5 divided by x, because 3.5 is the opposite side, x is the apothem's length, which is the adjacent side. And so you should have found x to be 4.82. Now you're supposed to find the area of the triangle. And hopefully you find the area of the triangle by multiplying that by 7. The apothem's length by 7 divided by 2 to find the area of the triangle, which is 16.87. And for the pentagon, there are 5 triangles, so the total area is going to be 5 times 16.87, which is 84.35. Then finally, I would like to try to do an independent practice of finding the area of this octagon given that the side length is 6 meters. And that is it for today. Please enter in the in the table of content that today we covered the area of a regular polygon. Thank you for watching.